Okay, so you're going to have 2 questions over EMR ranking and calculation. So I think there's going to be 1 ranking question and then 1 calculation question. Easy money here. Easy money. So number 6 says, what is the correct order of increasing energy? So when we say that, as we list them off, your energy will be going up. Okay? Energy will be going up. So you're going to start off with the smallest and give me the biggest. If it would say decreasing, you're going to start off with the biggest energy and then list off smaller and smaller. Why can I not do this? Okay. So when you see this question, I want you to go ahead and just write out your spectrum. So start with smallest. We have radio waves. Then we have microwaves. Then we have IR. Then we have our visible region. Then we have a UV. Then we have X-ray. Then we have a gamma rays. Okay? So 7 total. In that order is increasing energy. Okay? So, looking at A and B, microwaves are pretty small, so we'll keep those. C says microwaves first. Okay. And D says X-rays. X-rays, gamma rays, and then microwaves. Microwaves are the smallest, and we want it increasing energy. This is not doing it for me. Nope. Okay? Let's try A. We have microwaves, visible, UV, X-ray, and gamma rays. That seemed to be increasing. I'll put a question mark there. B says microwaves, X-rays, gamma, then visible. We went back, so that's wrong. C says microwaves, UV, visible. Went back. That is also wrong. Okay? So A is your answer. If a photon's wavelength is 663 nanometers, what is its energy? So, again, the equation that I want you to know for the test, it will not be given to you. You have to manipulate the 2 equations you are given, which are E equals HV and C equals and V equals C over wavelength. So then you combine these and do E equals HC over wavelength. We want this, because then we can get wavelength and then find energy. Okay? So wavelength is 663 nanometers. We do not want it in meters. Nanometers, we want it in meters. So we do 663. Since it's nano, it's going to be 10 to the negative 9. 663 times 10 to the negative 9. Okay? We want to make that like a whole number. So we're going to move it over twice. When we move it over to the left, that means we're going to add to our exponent. So negative 9 plus the amount of times we moved it over, which is 2, which will give us a negative 7. Now we're going to multiply it by Planck's constant. Let me pull that up real quick. think it's... Okay, 6.6 times 10 to the negative 34. Okay, so we have wavelength right here. Oops. So we're going to do 6.6 times 10 to the negative 34 for Planck's constant times the speed of light, which is 3 times 10 to the 8 meters per second. And then we're going to put wavelength, 6.63 times 10 to the negative 7. We'll just leave these as, we'll round the decimals. So this rounds to 7, and this rounds to 7. Okay, so 7 times 3 is going to be 21 times, so we're multiplying these exponents up here, negative 34 plus 8, that's going to give you 26 times 10 to the negative 26. Then we'll do 7 times 10 to the negative 7 right here. Okay, 21 divided by 7 is 3 times 10 negative 26 minus negative 7, double negative, add. So negative 26 plus 7, you're going to get negative 19 as our energy. 3 times 10 to the negative 19 is correct. So when a given molecule absorbs a photon of infrared radiation, what happens? Okay, so you're going to get one question on this, on your test. Be prepared to answer it. So infrared radiation. There's one key thing that we know about infrared radiation. And that's it causes the molecules to vibrate. Okay, so remember those slides that I made with the characteristics. You should know each one of those. IR causes it to vibrate. Rotation is microwave because it rotates your food. Electrons being excited is going to be visible and UV. And it promotes electrons into bonding is none of them. Okay, so know your characteristics that we talked about during class. 9. Failure of classical mechanics, photoelectric effect. You will have 2 questions on this. One right here and one right here. So radio frequency radiation has what kind of impact on matter? So remember, matter is electrons. So radio frequency is just another way to say radio waves. Okay? And we know that nuclei spin is a radio. Okay? I don't believe any of them cause your electrons to spin. Oh, no. JK. Microwave does. Microwave cause your electrons to spin. And nucleus to split, we know is gamma. And the molecules to rotate is also microwave. Okay, so we know that the answer is A.